Hey folks, Mr. Nickel here. This will be a longer video. We're going to go through naming and drawing compounds with multiple functional groups. It can be a confusing process, and I want to walk you through the steps that I take when I'm naming functional groups. So let me just flip over to my screen here. Boom, there you go. So we're going to look at this first molecule here. Now, whenever I'm looking at drawing or naming a compound with multiple functional groups, I always look at a couple things. One is to list all the things. That's my first step, is always to list what things or what stuff do I have that I need to be concerned with. Number two is always to number the carbon chain. That can usually be a pretty tough process. It involves priority. And so the third thing that I usually look at is the priority chart. And then the last thing that I always do whenever I'm naming something is combine all of those pieces of information together. So looking at this first molecule here, I can see a couple different things. I have a cyclohexane. That's that 6-carboned ring in the middle here. I can also see that I have a double bond. So what I'm going to put is just an ENE like this. And that will communicate to me, okay, I have a double bond somewhere in this molecule. One of the things I want to note is that this E at the ending of cyclohexane is flexible. It's not necessarily going to be a cyclohexane. That's not necessarily the ending I'm going to stick with. But I want to put it there so that I know that, hey, I have a cyclohexane. Another thing that I have here, I can see that I have a methyl group in this. So I'm going to say I have a methyl group present in this carbon molecule. So the next thing to do then is to try and number this carbon chain. To do so, we're going to consult the priority naming chart. You can see that we have a cycloalkane up here. We have an alkene down here, and then we have our alkyl group way at the bottom. So what we know from that is that this methyl group, we don't really care about it. It can have the highest number possible, and we don't care. What we do want to have the lowest number is the cyclohexane. But because cyclohexane is the main parent chain, it does not get a number. It is just a cyclohexane. So what we then move to being concerned with is this ENE. We want that to have the lowest number possible. And it turns out that if we number 1, 2, 3, 4, we end up with the lowest numbers possible for each of those functional groups. And so now what we know is we have a 1 ene and we have a 4 methyl group. So those are the two functional groups that we have. We want to then start combining the little pieces of information. So we're going to have a 4 methyl. And then what I'm going to do, some of you will want to put a 1 cyclohexene like this. Cyclohexene. The problem with doing so is that these numbers always communicate the location of the next functional group. So if we have a number 1 here, the next functional group is this cyclohex. And that means that somehow on carbon number 1, there is a cyclohexane. That doesn't make any sense with our molecule. And so what we actually need to do is change the order that this is written. And so it'll be 4-methyl cyclohex. And we said that we need this ENE ending. So it's cyclohex-1-ENE. So now what that communicates is that on carbon number 4, there's a methyl group. And then it's all part of a cyclohex. But on carbon number 1, there's also a double bond. And so that's how we take all the different pieces of information and chunk them together into this one name of the molecule. And so that's how you do naming of this particular molecule here. We're going to advance to the next one here. Looking at this next molecule, I can see that I have a couple different functional groups right off the bat. I can see that right here I have a ketone. So I'm working with a ketone. I can see that right here, I'm working with an alcohol. And I can see that my main carbon chain here is 1, 2, 3, 4 different carbons long. So that's a butane. And again, that can change. The E might change. We don't actually really know. Now, the two names for what we need to really consider is we have a ketone and an alcohol. We need to consider what numbers can we give them. If we scroll up a bit, we can see that a ketone has a slightly higher priority than the alcohol. And so what we're going to use is this ONE ending. Okay, so for the ketone, we want to use the ONE. For this alcohol, because it is a lower priority, we are going to use the hydroxy prefix. The other thing that we need to do now is start numbering. So where we get the lowest numbers possible is if we put this as carbon number 1, 2, 3, and 4. And once we have those, we can see that we have a 1-hydroxy and we have a 3-one. So now we want to put these numbers together. So we have a 1-hydroxy. And in this case, we do actually want to interrupt the hydroxy with the 3-butanone. So the butan isn't actually a functional group. It's just saying this is the main length of the carbon chain. And so where these numbers and words come together is that on carbon number 1, there's a hydroxy. Well, I know that a hydroxy is an alcohol. On carbon number 3, there's an one group. So I know that on the 3rd carbon, there is a ketone present there. And so that's the name of that molecule. To keep advancing, draw my red line here, boom, to divide this up, we have another molecule at the bottom here. And I can see that I have a couple different functional groups. I can see that I have this double bond, so I know that I have an ENE somewhere. And I can also see that I have an alcohol. So this alcohol will be either hydroxy or it will be the other ending for alcohol. So what we need to do is check our naming priority group. We see alcohol all the way up here with the OL ending. And if we scroll all the way down here, we can see our double bond ENE. So alcohol is being slightly higher than the alkene. We want to give the alcohol the naming priority and give it the suffix. So we know we're going to end with OL. What we also know is that this is on carbon number 1, and we know that this ENE is going to then be on carbon number 1, 2, 3, 4. So this is on carbon number 3. And again, we're dealing with a 4-carbon long chain, so we're dealing with a butane. So as far as naming this one goes, we're going to go but. And then instead of putting En, so what we're going to do is we're going to go buten. And to communicate where this double bond is, where this En is, we're going to put 3-buten. And then we're going to interrupt this and put 1-OL. And the reason that we do this is so that the 3 lines up with the En and the 1 lines up with the OL. They come right after one another so that then we have 3-buten, 1-ol, telling us that we have a double bond on carbon number 3 and an alcohol on carbon number 1. So that's how to go from the drawing into the name. I think the drawing into the name is the much more difficult part. I think going from name to drawing is a little bit easier. So here we have the name, very long one, 3-methyl-2-ethyl-4-hexanoic acid. Whenever I'm going from name into drawing, I always start with the parent chain. And from there, I assign numbers. And we can do them however we want. And then 3 is we place the functional groups. So here I can see that I have a hexanoic acid. So I know that I'm going to have 1, 2, 3, 4, 5, 6 different carbons there. And then from there, I'm going to just assign numbers. 1, 2, 3, 4, 5, and 6. And from that point, all I have to do is start chunking in all of the different pieces of information. I know that on carbon 3, there will be a methyl group. So there's my methyl group. On carbon number 2, there's an ethyl, a 2-carboned alkyl group. So there it is. On carbon number 4, notice that I'm just tracing number, word, number, word. Here we have that weird hex N. So this carbon number 4 tells me that on carbon 4, so between carbons 4 and 5, let me draw that a little bit neater, there will be a double bond for us. So between carbons 4 and 5, there's a double bond there. And then I have this oic acid at the end. And we know that the oic acid must always start off our molecule. So we know that there must be a double bonded O and a OH present on the end there. If you're wondering why I drew it as HO instead, it's that this oxygen is connected to the bond by the drawing. It just makes it a little bit neater. It's sort of a chemistry nomenclature thing. So there you go. There you have it. That is what that molecule looks like. If we keep advancing here, and I draw a red line in between our next one, we can see that we have our next molecule. We have a 3-bromo-1,1-dimethyl-cyclobutane. So the functional groups that I have, bromo, dimethyl, and then I have a cyclo as well. I have a cyclobutane, so what I'm going to draw here is a 1, 2, 3, 4 carboned cyclo here. So I've drawn the cyclo and I've drawn the butane as well. On carbon number 1, so I'm going to number my carbons 1, 2, 3, and 4. Again, it doesn't matter where you put those numbers. I'm going to have a dimethyl. So I have a CH3 here, and I also have an H3C. Again, it's just that the bond is connected to that carbon. It's a nomenclature thing. So I have 1,1-dimethyl. I have a cyclobutane, and the last thing there is to draw the 3-bromo like such. And there you have 5 different examples of how to draw and name compounds with multiple functional groups. Again, the order for draw to name, I think drawing to naming is much more difficult. List all of the things, number the carbon chain, do your priority chart, and then combine all of those different pieces of information into a name. Again, that's a much more challenging process than when we have the name and we get to draw it, which is do the parent chain first, assign numbers, and then place your functional groups after that point. That's how to draw and name functional groups on molecular compounds that have more than one functional group or substituent. I hope that was helpful to you, and we will see you all in the next video.